So just like with the last set of videos, what you should do is try the problem first and then check your answer against the video. If you get it right, you can skip the explanation, and if you need extra help, you can watch the explanation and you can reach out to me. So for number 1, pause the video, try it first. The answer to number 1 is D. To get there, we're going to let u be x to the 3 halves. So du dx is 3 halves x to the 1 half. Oops, 1 half. So du, and that 3 halves, I'm just going to make it a 2/3 on the other side. So 2/3 du over x to the 1 half is dx. So we start to substitute. Here's the original problem. We have root x times sine of u times dx is 2 du over 3x to the 1 half. I'm going to write that as root x, so it's a little clearer that we can clear those out. So now I have 2/3 sine of u du. So my antiderivative, the antiderivative of positive sine is negative cosine. Don't need that. So negative 2/3 cosine u plus c. And if we remember that u is x to the 3 halves, then we will have our final answer, negative 2/3 cosine x to the 3 halves plus c. For problem 2, the answer is going to be D. And this problem is a little different from the others, and if you've tried it already, you might know why. This type of problem is pretty common on the AP exam. I don't know what the exam looks like this year, but they like to do this. They like to tell you what to make u. So if we have that, so u is 2 minus x, du dx is negative 1, so negative du is dx. So we start to make our substitution. So I have x root u times negative du. And we have a problem here because this x doesn't simplify with anything, that x right there. So we have to get a little creative. We know, so we're looking to substitute out the x. We want u, we don't want x. Well, we have this. This is going to give us the extra substitution we need. If u is 2 minus x, then that means that x is 2 minus u. And that gives us this additional substitution, 2 minus u. Times, I'm going to move that negative out in front. Another thing that we have to do here is, since this is a definite integral, the 1 and the 3, we need to rewrite those. So if u is 2 minus x, if I plug in 1 for x, I get 1. So that's my new lower bound. If I plug in 3, I get a negative 1. So we have a couple problems going on here. So we look through the answers and we can eliminate this one and this one because I have 1 to 3 and 1 to 3. We should be able to suspect already that D is going to be our answer because of the u minus 2. But let's talk for a second on how our problem has 1 to negative 1. And we have a negative 2 minus u, but the answer is negative 1 to positive 1, and it has a positive u minus 2. So one thing we can do is flip the 1 and negative 1 by factoring out a negative. So if I make it negative 1 to 1 instead of 1 to the negative 1, switching the a and the b values, it just makes the integral negative, which really would cancel out with that negative on the inside. Now this answer, 2 minus u, does not perfectly match their answer of u minus 2. So I am going to send this problem to another math teacher and see if they can check it for me. But these are the steps of how we would do this problem. I'm not quite sure why my answer doesn't match theirs, but I'll double check and get back to you guys. On this question, the final answer is going to be C. Usually with these problems, you just kind of have to play around with it a little bit. So if I look at this first problem, or this first part of the problem, so if I had the integral from -1 to 3 of f of x plus k, if I had to evaluate this, I would take the antiderivative. The antiderivative of f is big F. And if I were to plug in -1 and 3, I would have 3 plus k minus f of -1 plus k. And we're told that this is equal to 8, so this is 8. If we look at the other side, so if I have k minus 1 to k plus 3, f of x dx, so I would take the antiderivative, which again would be big F, going from k minus 1 to k plus 3. So that would be f of k plus 3 minus f of k minus 1. Now that happens to be what we got over here when we just played around with the first part. And we were told that that was equal to 8, so this has to also be equal to 8. So a lot of these involve just playing around and seeing if you can find a relationship between the two problems that you're given. On this problem, so we're on problem number 4. Where are my answers? On problem number 4, looks like the answer is going to be A. So if I treat this in a similar way as before, so for the first part we know 0 to 6 is 12, so that would be big F of 6 minus big F of 0 is 12. Now, unfortunately, with this, we can't evaluate it as directly as we could on the last problem. This, because it's a 6 minus x, it's really the negative there that changes the problem. This is now a u sub problem. So if I want to evaluate 0 to 6 of f of 6 minus x, and this, you might be able to do it in your head, but if you can't, here are the steps for it. U would be 6 minus x. Du dx would be -1, so negative du is dx. And we would start to make our substitution. So now it's f of u times negative du. 0 to 6. If I plug in 0 to 6 minus x, I get 6. If I plug in 6 to 6 minus x, I get 0. So we saw this on an earlier problem in this packet. It might have been 2 problems ago, but to switch the 0 and the 6, it's going to become negative. And I'm going to take this negative and just bump it out in front. So those two negatives, they're going to cancel each other out. And again, if I were to take the antiderivative, this would be f of 6 minus f of 0. And we already know that that's equal to 12.